This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com.
Noise pollution is a huge benefit. The other thing is maintenance. Most electric machines have very few moving parts as compared to an internal combustion engine machine. In terms of maintenance and things that could potentially break, you've got a lot less.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, we ask that you follow us on Twitter. You can find us there at the NFPA. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is actually one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts. We're on Spotify. We're on a lot of the other podcatching services. Wherever you find us, subscribe and then give us a quick rating. Those ratings really do help promote the show, let more and more of our friends in the industry join in on these important conversations. On today's show, our guest is Marty Christensen. Marty is the market manager for e-mobility at Hydac, a provider of fluid power solutions to OEMs, manufacturers, and end users in a variety of heavy-duty mobile and industrial equipment. Marty was a speaker at one of our recent quarterly conferences. You can learn more about those conferences on our hub, nfpahub.com. But today we invited Marty into our forum to learn more about the content of his presentation, which focused on e-mobility and the electrification of off-highway hydraulic equipment. So Marty, welcome to Fluid Power Forum.
Hi, Eric. Thank you. It's my pleasure to be here.
We're glad to have you on the show. I know you had a great presentation at that conference I mentioned, but I'm happy to extend some of that information out to our listening audience. Tell our listeners a little bit more about yourself. What's your background? How'd you find your way into Hydac?
It's a bit of an interesting story. I actually started my career in the heat transfer and cooling area of mobile and industrial equipment. I was a cooling application engineer for the better part of my life, in totality about 20 years. So about 3 years ago or so, I kind of tripped over a couple of cooling applications for some electrical vehicles and some electrical charging infrastructure. As that started to occur, we started to see more RFQs come in and increase, and kind of the decision was made for me, since I had some experience with this, to take a more active role in the e-mobility area.
And that was all at Hydac?
Make sense.
That was all at Hydac?
That was all at Hydac. Yeah, correct. I've been with Hydac for about five years, but the e-mobility section came all while I was at Hydac.
And so, when did you first get exposed to fluid power as a discipline?
As a discipline, it was in the kind of in the industrial cooling side of fluid power. So manufacturing heat exchangers for industrial equipment, so machine tools, presses, etc. That gradually transitioned into mobile equipment, designing custom OEM radiator packages for off-highway equipment. Okay.
So it sounds like you've had a couple of interesting pathways into the industry then from different perspectives.
I have. It's forked. Yeah. To be sure.
Well, we're all the island of misfit toys here in the fluid power industry in so many ways. So
exactly, it's a small world.
It is, and one of the best things about our industry is once you're in it, you never leave it. So people love it inside the industry. Well, great. And tell us a little bit more about Hydac as a company. It sounds like they make a variety of different products. What do they do?
Hydac makes a large variety of different products. They design and manufacture a very comprehensive line of innovative and reliable hydraulic, electronic, and control fluid conditioning solutions designed for mobile and industrial applications. Mobile is probably a larger portion. But one of the things we like to do is leverage our product and application experience to collaborate with our customers to develop solutions that solve our customers' challenges and then increase the value to their end customers.
Yeah.
Specific products include filters, accumulators, valves, coolers, accessories, and a variety of electronics.
That's going to put you in a lot of different markets, I'm assuming. You said both mobile and industrial, right?
Both mobile and industrial. It's heavily mobile, but yes.
Mostly mobile. Okay, great. And how long is Hydec? I mean, they've been around a long time, right?
Yeah, they've been around almost 60 years. I think I think they started in 1963, so almost 60 years.
Right. Well, they have a proud history, I know, of serving the industry and serving all those different markets that we talked about. So, so I guess we're going to focus on e-mobility. I know that was the topic of your presentation that we mentioned, and what we want to get into today. I'm not too familiar with that term. I wonder how many of our listeners are. Maybe that's the best place to start. What is e-mobility?
Sure. Well, there's a couple different definitions that people like to assign to it, and I'm going to sort of give you what the Hydec definition is, or what our definition is. But in short, it's powering of any vehicle or machine via a means other than an internal combustion engine.
Okay.
So that doesn't. But that also includes, and is not, also includes charging infrastructure, fuel cells, and even hydrogen production itself. So it is electric vehicles, electric cars, but we take it in totality, a really holistic approach to everything that is either directly related or helps support electric vehicles.
Okay, so like you said, there's a variety of different, I don't know if fuel sources is the right way to say that, but I mean, the hydrogen certainly is a new area. You're in that space as well?
It's a very new area.
Yeah.
We do have some products that are designed specifically for hydrogen and applications. We're in applications that deal with hydrogen production, transportation, etc., but then also on the fuel cell side.
So it's basically any technology that replaces what would ordinarily be an internal combustion engine on
Correct.
Either a piece of machinery in a plant or a vehicle that moves around outside and does work.
Correct.
Okay, so that's what we mean by e-mobility.
Yeah, that's the way we define it. Okay. A lot of people think of it as like electric cars, but and that's part of it, but that's not all of it.
Yeah, well,
we look at it,
and I appreciate that clarification. I mean, I think that's really one of the most interesting things about it is that it's finding its way into so many different places because of that. Kind of that all-in approach, if that's the right way to say it, for the different kinds of technology solutions. I wonder what industries or machines are primarily moving in this direction right now, at least from a Hydec point of view. Where are you focusing most of that attention?
We're focusing most of our attention right now on infrastructure and on the off-highway equipment itself, for a large reason that those are our existing customers.
Okay.
But we also extend that to looking at some of the on-highway customers as well, particularly when it comes to the fuel cell and hydrogen technologies.
Right. Okay. And so whether it's fuel cells or whether it's hydrogen, as you said, it's called electrification. It's electrifying the machines of one kind or another.
Yes.
Yeah.
Correct.
And so what are some of the benefits of doing that? Like, why is that such a trend, if you will, in the marketplace right now?
Well, there's two primary benefits, and one of them is sort of going to be government mandate driven. I'll touch on this a little later too, but there are some mandates from governments where you have to have certain clean machines, but there are other benefits too. So for example, if you have a machine that needs to do some line work in a residential area and you've got a power outage and you need to do that it would be most beneficial to do that at 3 or 4 o'clock in the morning. They're very quiet. So noise pollution is a huge benefit. The other thing is maintenance. Most electric machines have very few moving parts as compared to an internal combustion engine machine. In terms of maintenance and things that could potentially break, you've got a lot less.
So compliance with government regulations and lower noise and simpler maintenance is what I'm hearing.
Simpler maintenance.
Yeah. As what's really driving the market towards those new technologies.
Correct.
Right. Well, I know in your presentation, Marty, you gave an example of a wheel loader, if I remember correctly.
Hmm.
And maybe that's a good way to talk more about the specifics of, e-mobility and the technology, to put it in the example, of a machine that people can wrap their heads around. So, first of all, let's start with what a wheel loader is. Maybe people aren't familiar with that term. Can you describe what that machine is?
Sure. Another name for it would be a front end loader, or maybe a bucket truck. In terms of a very common, on a smaller scale example, would be like a skid steer or a bobcat in specifics.
Right.
But in simplest terms, it's a tractor with the bucket on the front. You see them at all kinds of construction sites, but it's not limited to that market. They're used for hauling material around, loading dump trucks, etc.
Right. It's kind of your catch-all machine, right? It does everything and
it's
everything.
It's a go-to machine. Yeah.
They're very popular in rental fleets, if I know my business correctly, right? So
Yes.
the smaller contractors can really use them for almost anything, and do sometimes, right? They push the limits.
Yep. Yes.
So why is the wheel loader such a good candidate for electrification or e-mobility, as we're describing it here?
It's a good candidate because it's got a lot of work functions that could benefit from electrification. So you've got travel functions, you've got the steering functions, and then you've also got lift and tilt functions where you're lifting a load, but you're also operating a tilt function on the actual bucket itself. So it's kind of got it's a very simple machine, but it has all the facets that a lot of other larger, more complicated machines can have.
Mm-hmm.
So it's got not only travel and steering, but it's also got some work functions. Now, other machines are going to have more work functions, but it's a very good entry level machine. And again, they're very popular and very scalable.
And when we're talking about electrification, we're electrifying the power source essentially, and that's going to drive both the locomotion of the machine, but also those work functions, as you're describing.
Correct.
So, I mean, how do you approach that process? Is it all at the same time? Is there a progression of how you apply the electrification technology in that space?
Generally, we kind of go through phases of electrification.
Okay.
So what we define as a sort of a phase zero, if you will, that's kind of where the world looks today and sits today. That's what everyone is kind of comfortable, familiar with. Diesel engine, drives a main pump, might drive a hydrostat, a series of pumps and motors, and it kind of does everything.
Mm-hmm.
As we progress into what would we look at it as a phase one is just, okay, we're going to remove the internal combustion engine, take that out, and we're going to replace it with the battery electric system. But you're going to have a battery, and it's going to give power to a single electric motor that's then going to power everything that diesel engine was powering. It's not terribly efficient, of course, but it's definite general proof of concept.
Okay.
What would this architecture kind of look like if we did this? And it's also a big point of, how is our controller going to talk to this? How are we going to talk to these different components that we're adding to the system? We've got a battery in there now. We've got an inverter converter in there. We've got an electric motor. How do we talk to these different components of the machine? It's really the initial R&D function. And then as we progress into different phases, the phase two would basically be making it an electromechanical drive. So we would make the drive function, the travel function, we would couple that gearbox directly to an electric motor, and we would have a second electric motor do the other three functions, the steering, the lifting, the tilting, et cetera, any of the work functions.
Right.
So now that becomes more incremental on the controller and on the cooling side, if there's cooling involved in the motors and the inverters, because we've already done it before for the one big one. Now we're just splitting up a little bit, so we're incremental on that. And again, as we progress into phase three and ultimately phase four, you're breaking out the function so that each individual powered function has its own electric motor and or converter if necessary.
Right. And as you said, on these wheel loaders, they could have as many as 4 or 5 different functions going on.
Correct.
So I'm curious, how does an engineer kind of approach that that challenge, right? I mean, is it really as you just described it? Well, let's get the fleet up to phase one, and then we'll start doing phase two, or do customers want to go directly to phase four, or how does that work?
No, you really wouldn't. I've never seen anyone do it all in one jump. And that said, it is very new right now. But the customers that I have seen and talked to that are doing it, a lot of them are either in the phase one or phase two. There even are some phase two machines that are out there right now where you have an electric drive and hydraulic power of or a diesel power of other functions.
Right. So there's still an internal combustion engine on those machines then that's working in parallel with the electric motor?
Not necessarily.
Okay.
It's still electric, but they haven't broken off all the separate individual functions. So they've coupled an electric motor to the travel function, but they only have one that's doing all the other hydraulic
Okay,
functions. They
I
haven't
got it.
broken them all off individually yet.
Right. Yeah. I mean, to me, it's just fascinating to think about, and I guess we want to get into this part of it next, if you will. We've reached a point in our show where we want to take just a quick break and provide a update on some other fluid power industry opportunities for our listeners. We'll continue with our guest in just a moment, but first let me tell you more about IFBE, the International Fluid Power Exposition. IFBE is the place where you'll learn everything you need to help your company stay at the forefront of the megatrends affecting your business and industry. From sensor technology and data analytics to robotics and automation, you will see the latest innovations in fluid power that will help your machines and applications achieve your technology, performance, and business goals. Only at IFBE can you have in-depth technical conversations with other engineers and executives to spark new ideas, or talk with suppliers about your specific challenges and the solutions they offer, or find new suppliers and new ways of doing things, or attend innovative education classes and sessions covering the latest fluid power topics and industry trends, including courses providing PDHs. No other trade show brings as many sectors of the fluid power, power transmission, and motion control industries together in one place. This event only happens once every 3 years, in conjunction with ConExpo ConAg, the largest international gathering for the construction industries. And our next IFBE show will be held March 14 through 18, 2023 in Las Vegas, Nevada. To learn more and to reserve your place, visit ifpe.com. Okay, we're back from our break. I'm talking with Marty Christensen of HYDAC, and we're talking about different phases of electrification on, in this example, at least a wheel loader, but certainly on other pieces of off-highway equipment as well. I'm assuming it would extend. And Marty, I was just about to ask you, and you mentioned it in passing, this is a fluid power show after all, so we want to talk about the hydraulics
Sure.
that in most of these cases are still on the machine, right? So a lot of time when people are thinking about electrification, they think we're taking the hydraulics off these machines and replacing it with electromechanical actuators of one kind or another. That is happening in some spaces, but to a large part, you're still powering the work functions with the hydraulics. Is that right?
That is correct. In most cases, in most ranges, all the work functions will still remain hydraulic. As I mentioned, the travel function will most likely be electromechanical. The steering may or may not be, but a lot of this will depend to see what testing is necessary and what the actual power requirements are for the tasks. In most cases, what we've seen is the work functions that are hydraulic are going to stay hydraulic.
Right. And that's really a symptom of the kind of the power density requirement for a lot of these functions.
That's exactly something, the power density.
Yeah.
Correct.
So even though these machines are increasingly driven, if you will, or they move around by electric drives, and the power source is still electric, we're still driving hydraulics to do the work functions.
Correct.
So that must be where you get into the different phases of how many different electric motors do you need? One to rule them all, if you will, or different, motors on different functions. That's really, as I heard you talk about the different phases, that seemed to be the discrete part of that equation. Is that right?
That is a differentiation as you go through the different phases, trying to decide how many motors you need and how many functions you need to power at a single time. Most of the time, what we're going to find is that only one function really needs to be powered at a certain time. And anything, if you're powering other functions, you're wasting power.
Right.
and charge on your battery.
Right. So I guess that gets into the different, I mean, how do you make that decision essentially? Like what's the benefit versus cost associated with more motors on the machine versus one to kind of drive multiple functions?
Well, it gets into how large of a battery do you need? If you are powering functions on the hydraulic side that you're not using, or giving energy to motors that you're not using, that's a drain on the battery. And that gets into you either need a really big battery, which takes up a lot of space and a lot of weight and
Right.
costs a lot of money, or can I go with a smaller battery that doesn't have that much, but then I don't have to charge it as often.
And that's probably a different calculation for every machine and what the work functions are going to be on that machine.
Yeah, every machine and duty cycle is going to be different.
Is there much change in the workflow for the operator if in those different configurations, or is it still look and feel like the same machine to them?
No, the idea is for that to be transparent. It should be the same machine. It's still going to work the same way, and they really shouldn't notice anything different other than the noise level would be quieter, obviously.
Right. They can finally hear that hydraulic pump, right?
They can hear the hydraulic pump or the fan kick in, yeah, for the cooling, correct.
Well, the cooling's another big piece of it, I know. So, I mean, that's as you said earlier, that's one of your areas of expertise and background, at least. That's kind of how you came into this equation, the different cooling challenges. What does that look like as you continue to electrify these machines? Does that need go up or down in terms of the need to cool the pieces of machinery?
So as you go through the different phases, as you kind of add additional motors and inverters, I mentioned earlier, it's kind of an incremental process. So the actual cooling requirements might change slightly, but it would still be a single centralized cooler. What you would have to then do, though, of course, is some of the hose routing on the for the coolant loop would be a little bit more complex. So that would be one change. The cooling is really not very high because the components are so efficient. The electrical components are so efficient.
Right. Yeah, exactly. I would think that it would be it would have lower requirements for cooling in this configuration.
Incredibly lower requirements.
Yeah.
The only caveat there is that they need to operate at a slightly lower temperature than your standard diesel engine would want to operate at.
Right. Well, that would be another benefit, I would think, of moving in this direction.
Correct.
So how proven is this technology? I mean, I don't know how to ask the question. Let me start again. How ubiquitous are these new technologies in the marketplace, right? Will you find most of the machines have some level of electrification in them, or is it still rolling out to the marketplace, if you will?
It's still rolling out. There's really a lot of R&D and testing going on by OEMs to see what they're going to offer. Are they going to offer something fully electric? A lot of what I've seen right now is looking at stuff that's hybrid electric, where you have a battery system, but it has a range extender in it, as we talked about, maybe a smaller diesel engine.
Mm-hmm.
On it that kind of helps and then in that case, the battery acts as kind of an electronic accumulator to relate to the hydraulic world, to kind of take over the ebbs and tides of what the machine requirements are.
Oh, that's an interesting concept. I guess I've not heard it expressed that way before. So, I know getting energy in and out of a battery compared to a accumulator is a much different engineering challenge, right? I mean, the charge and the drain rates on most batteries is different, right?
Yes, depending on how the functions are being used too. So for sure.
So kind of banking all of that energy in the battery, it's more of a slow drip coming out of it, I'm assuming.
Yes. So the way that the range extender would work is for the hybrid vehicles is all the functions could be powered by the battery, and then if it needed to have if there was a peak, then the diesel engine would kick on.
Oh, I see. Okay, right. Yeah, that makes more sense. It's like my car goes silent at the stoplight now, right? And
the auto stop start. Yeah.
The first time that happened, it really scared me. It's like I thought something happened to my car. So, but
it's like driving a golf cart. Yeah.
It's the same kind of thing. Yeah, interesting. Okay. That sounds like it's technology that can be retrofitted onto existing machines, or do people have to buy this stuff new out of the factory?
The design would have to be new. There, you can bring a vehicle if it's, so for example, if you have an on-highway vehicle, like let's just take a delivery truck, you can bring that into certain companies and say retrofit this with an electric, drivetrain. On an actual mobile piece of equipment, like a hydraulic piece of equipment, that's a little bit more difficult to do. There's a little bit more that goes into that.
Right.
So that's not to say that the outer shape of the machine changes a lot. It's just kind of what's under the hood now is different.
Right. So what do you think this is something, as you said, that is slowly coming onto the marketplace, but steadily, I think is the right way to say it.
Steadily is a good way to say it.
Yeah,
yes.
It's certainly, I don't think anybody's under the illusion that this isn't going to take over, right? This is going to be the way things are. Where would you estimate that we are in that transition right now?
I would say we're really, especially for the off-highway market, we're really in the early stages.
Okay.
So a lot of folks are kind of doing the R&D stuff. It's definitely evolving. But it's because it's so new to everyone. And when I say that the technology is evolving, and especially on the battery side.
Yep.
But one of the terms I like to use frequently is we don't know what we don't know. So we're kind of like feeling our way through a dark room with a lot of this stuff, trying to figure out where we go as we design these machines and then this equipment. We think we're going in the right path, and then we might hit a bump, but we have to change directions a little bit, and now we're going to go this way,
Right.
and that's okay.
Yeah.
But I would think realistically, probably in the next 3+ years, I would see a lot of companies have at least an offering for a hybrid, if not a fully electronic version of some of their high runner machines.
Right. Do you sense any hesitancy on behalf of those either OEMs or end users to move in this direction? If so, like, what do you think what is that hesitancy?
So cost cost could be one potential, and time, but I also think that it's a lot of the fact that the infrastructure isn't really there, or they're concerned the infrastructure is not there to support an electric vehicle that's out in a field somewhere.
The charging infrastructure specifically.
Charging infrastructure,
yeah, right.
Exactly. How do we get, if it's a fuel cell, how do we get hydrogen to the machine? If it's electric, how do we get electricity to the machine? It's a different scenario if your machine is coming back to a terminal or a garage every day at the end of a shift. And I use the example of like equipment for municipalities, call it street sweepers or utility equipment, where they're coming back to someplace,
right.
But if you've got a wheel loader or a large excavator or a great big crane, that's going to stay at a job site until that work is done. And that could be somewhere between Fargo and Bismarck, for example.
Right.
And there's no real good way to get charging to that machine. So I think that's a hesitancy.
Yeah.
And another hesitancy is that's people have been talking about a lot is the electrical grid able to support charging all of this, equipment?
Right. Yeah. I mean, those are big questions, right? And I don't know that anybody knows the answers to those right now. It's one of the benefits of of gas, if you will, is that the infrastructure is
Right.
there, and the machines themselves go to the islands to fill themselves up, essentially. Right. So
Yeah, right.
Yeah.
And I use two analogies for that. One of them is more recent than the other. The first analogy is when Tier 4 final came out for diesel engines, and we had the SCR systems, and that was announced in the late 2000s. And you need this diesel exhaust fluid, this DEF. Well, I can't get that anywhere. How am I going to get that? Well, it took several years, but now that's very readily available.
Right.
Kind of the same deal with cell phones. 20 to 25 years ago, if you got too far outside a city or a metropolitan area, you didn't have any service. And now
Right.
that's changed too. So I think with infrastructure will come some level of adoption.
Yeah. And it seems like those wheels are starting to turn, right, in terms of building that infrastructure out. But it's still probably measured in decades, I'm going to guess, before we get to some level of ubiquity in that space.
Yeah, I mean, like I said, I would say probably at least 10 years before it's more or less commonplace.
Right. Right. Well, I'm curious, Marty. Yeah, I'm curious, Marty. As we said a couple times before, this is a fluid power show, so this is obviously very relevant to the future of fluid power technology. It has to interface with these new power sources and with this new infrastructure that we're talking about. I'm curious if you have any thoughts on changes or things that fluid power needs to adapt more. I mean, what's on the short list of things that fluid power technology needs to do better at if it's going to be part of this infrastructure going forward?
So on the short list, I think, as we talked about, the hydraulic functions are not going away, but I think we need to look at not just the individual hydraulic components themselves,
Mm-hmm.
but how the actual hydraulic system is designed and applied in vehicles. Are we going electrohydraulic? Are we doing more, open center? Where do the counterbalance valves, play in?
Mm-hmm.
Obviously there's a lot of efficiency in pumps and motors. We can get a lot of efficiency out of that, but the system in totality, how can we make the manifold design more efficient?
So there's
I think there's a lot of design stuff and design application that comes into that.
So that push for efficiency that's creating the trend towards electrification is going to spill over into the hydraulic system as well, I guess is what I'm hearing you say.
Yeah, the hydraulic system design, we have to remember that a diesel engine at best is about maybe 30% efficient. So anything downstream of that, you can make that as that could be fairly efficient. Let's just say it's 75% efficient.
Right.
But in an overall system efficiency, it's not really playing into the overall efficiency of the machine. Well, now you have batteries and electric motors and converters, and they're 95+% efficient. So now the downstream components become very important. And to be clear, it's not the efficiency of the component itself, it's the efficiency of how the system is designed.
Right. Yeah, and is that something that HYDAC is working on consciously as they try to roll out these new systems?
That is something that we actually try to take pride in, and we have actually been talking to our customers about that for several years. The difference is in how do you offset the expense?
Right.
So is it a CapEx expense on the front end where, okay, your end user won't see much, so they have to put in, 2 more gallons of diesel fuel at, well, whatever it is, it's more now than it was a year ago. But now in an electrified machine, it becomes more of a CapEx expense, because now I'm more efficient on the hydraulic side. Now I need a smaller battery. I need a smaller motor. I've got less space. I've got less weight, and my capital cost to sell that machine to the market is 20% less than it would be if I didn't, redesign my hydraulic system to be more efficient.
Right. Yeah, it's a lot of changes as you're describing. It really underscores how integrated all of these systems are, and how you can't just change one without affecting all of the other things that are going on the machine.
Yes.
Absolutely. All right. Well, Marty, we're coming up on the end of our time together. I wonder if you can look into your crystal ball and let us know to the degree you can kind of what's next on the horizon for either this technology or for HYDAC's role in it. What should we be looking for?
I think we should be looking forward, or looking to see more. The early adopters are going to be the ones that sell the municipal equipment. So your street sweepers, your utility folks of the world, your bucket trucks, etc. The other markets that are going to be very early adopters of this are going to be some of the mining stuff, your underground mining. Obviously, mining in general is very familiar with doing electrified machines, have been for years. But I think underground mining is going to be huge as one of what I would call the early adopters, and look for more of the small to medium OEMs to start coming out with or start looking at designing an electric version of one of their machines.
Fantastic. All right. Well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Marty Christensen, who has been my guest on this episode. If you'd like to connect with him, the best way to do that is via his email, and we're going to put a link to his email address in the show notes for this episode. We'd encourage you to reach out and learn more about what he's working on and what HYDAC is doing. If you're looking for more fluid power content like what we've discussed with Marty today, you can join in on those quarterly conferences I mentioned. You can learn more about those again at our hub, which is nfpahub.com. If you're a member of NFPA, you can actually access Marty's full presentation and download that and listen to the full information. Also, to see the latest fluid power technology and learn from industry experts, you should be making your plans now to attend IFPE, the International Fluid Power Exposition. Our next show will be March of 2023 in Las Vegas, Nevada. For more information, visit ifpe.com. This is Eric Lenke with the National Fluid Power Association, reminding you to join us next time in the forum.